Hello, welcome. So in this video, I'm going to be teaching you about generics. If you don't know what generics are, chances are you've probably used them in the past at some point. For example, if you've ever used a list before, and as you can see, this is in the System Collections generic namespace, you might have noticed these angle brackets. And that is because list is a generic class. It allows us to define the type that the collection is going to be. So for this, let's use string. And let's just call this games, and this is going to be equal to a new list of string. So then down here we can say games.add, and as you can see, it is giving us actual type safety here. It is saying that it requires a type of string. So if we just try to put in a number here, it would say no, that is incorrect, we need a string. So let's put in a game, Dark Souls. Cool, and then we could make another list down here where we would in fact use an int. So my ints, don't really know what a cool int list would have been. And down here we can say my ints dot add, and then as you can see, it's now giving us the type safety for an integer. So we can say 69. Excellent. So to understand this a little bit deeper, let's create our very first generic class. So as you can see, I've got just two files here, program and declarations. So this one's the program and this one's the declarations. I just figured I'll keep them separate. It will make it nice and neat. So over here, let's make a class, and this will be called generic class. And now this is where we put our angle brackets. So here we're going to say that there needs to be a type of T. Now T is just an alias, and it's convention in C# to make your first generic alias T, just like it's convention in your for loop to put I as the first iterator. So, and then you could go to like U and so on. You can have as many generic types as you would like in this generic class. So that's the only difference to make a generic class compared to a normal class, just adding these angle brackets and putting the alias of your data that you're going to put in. So now let's actually store what this data is going to be. So we can say public type of T, and this will be data. So now over here, we can actually create this class, this generic class that we've just made. So let's say var my class is equal to new generic class. And as you can see now, we can now put in our own type into this. So let's call this a string. Cool, so we have just made our own generic class in the same way that list creates theirs. We've got our class name and then the generic type that it takes. And if we just deconstruct this list class here, we will see that they do exactly the same. It is a list of type T. Right? List is just a generic class that is provided by C#, but they're using generics in the same way that we're using generics. So that's cool. And now here, we've got our little field here of data. We can say my class dot data is equal to, and as we're using a string here, it will say that data is of type string. So we can put in wobbly. Cool, this is a little bit messy, so we could actually add a constructor here. And in this constructor, it will take a type of data, and then we can just set our data is equal to data, just like that. So now, instead of doing it like that, we can just directly say right in here, wobbly. So now we have a generic class with a constructor that actually takes the type of T into it. And of course, if I change this to int, that would now say, no, this is a generic class of int, and I need an integer. Excellent. Now, generics is not just limited to a class, we can actually make a generic function. So we could do void. Let's call this function print, maybe. And it's going to be of type T. And then in here, it's going to take type T, and this will be the input. And now let's console.writeLine, and this will take in input. So now this function can take in any data type, and then we can print it to the console. So let's try that. Let's say print, and this will be, let's just put in an integer. Now, if we press play here, we'll see that it prints out 420. And we can reuse this function easily with even a string. So this will be, let's say loop hero, And then even further, we could, let's say we had a class here, public class hero. We could even do it with a new version of this hero. We can use this same code for everything. So let's try that. There we go. So obviously when there's a string or an int, there's special logic in those value types that behave differently when you print something out. Our hero doesn't, so it's just going to print out the name. Now, just imagine this was not just writing a line. Say it's doing something a little bit more complex, right? Without generics, you may have had to write a function for integers, for strings, and for hero, and all your other classes and structs, right? But with generics, you can now reuse that for all your different types. Okay, excellent. So let's actually remove this function, and let's actually put it in this function. We don't actually need this. We don't need this because we've already got the thing that we want to print. We're just printing data, are we? So we've got this generic class. It's got this function inside of it now. And now we can say here, my class dot print, and the output will be expected. It will just say wobbly, as that is, we're using a string here as our generic type. So being able to send anything into a generic class or function is great, but it can also be limiting. Like, it's actually too generic. What if we have a, in our hero class here, we've got a public void attack function. And let's also say that it's got a public int damage and also a public string name. Right, and then this attack function will just say console.writeLine, and it will say our name did damage. Okay, so now we've got a hero here with a name and damage, and there's a function on it, and it just prints this hero did this damage. Okay, so let's actually rename this generic class. Let's actually call this like hero helper or something like that. Okay, so we're making it a little bit less generic now. So don't get confused. This is not the actual hero, right? Our hero class is here. This is a hero helper. We're putting our hero into this as the generic function. So let's just move this just so we got a little bit of extra room here. So let's say from this hero helper, I would like to force my hero to attack. So we could have a function here called force hero to attack. And what we want to do is we want to make this data, which is going to be the hero, right? Call this function attack on this hero class, because we've sent in hero as the generic type. But there's a problem. As this is so generic, right? It doesn't know what it is. This T, as far as the compiler knows, is an int, right? It could be a dictionary, a key value pair. It could be a list. It could be anything in the world, which means it doesn't know what values and methods are actually on this thing. So as I said, being able to send in something, anything is good, but it's also a constraint. So we need access to this hero, right? So, and also just to iterate this fact a little bit more, let's say we've got a mage class, right? And that inherits hero. And let's say we've got a warrior class, and let's say we've got an archer and a million others, right? Say we've got a million other classes all inheriting from hero. And then let's delete some of this stuff. And I'm going to create my hero up here. So var warrior equals new warrior. So now I've got my warrior, and also I'm going to set its name to Tarodev and its damage to 420. Powerful. Okay, so we've got, well, that should be a lowercase. Cool. And now I'm going to make my hero helper. So I'm going to call this helper equals new hero helper. And I'm going to say this is going to be of type warrior, and it is taking in my warrior. So we're using this in the same way that we used our previous generic class. We're giving it the type that we want it to be, and then we're actually giving it the value. And now obviously we can still say helper.print, and this will print, and I'll just demonstrate that. It'll print the name of the class, warrior. Cool, but I want it to do more than that, right? This is a hero helper. I want to be able to force my hero to attack. So, as I said previously, it's great being able to put in anything to this generic class, but sometimes it's a limitation. So this is where constraints come into it, generic constraints. So we can say hero helper takes in type of T, where T equals a type. We're confining this generic method to have to use a specific type. This one will be of type hero. Okay, so now it doesn't matter if it is a warrior, a archer, a mage, or even just the hero itself, which we shouldn't let. Let's make that abstract. That's beside the point of the tutorial, but obviously you wouldn't allow your base class to be initiated as an actual hero. So this function is just saying, as long as T is of type hero, I'm good to go. And the benefit that this gives us is now we have access to the hero methods here. So now we can say attack. And before it didn't know that it was a hero, so we didn't have access to that function. And now on the flip side, as this is requiring a hero, we now cannot use an int here, right? We can't use an int here because this is not of type hero. So this allows us to be more flexible with what we do with our generic methods and functions. Okay, so now something a little bit more advanced. Let's make a factory method which will actually create these heroes for us, all from just one function. So let's say this is going to return type of T, and this will be our hero factory, and this will be a generic function, so type of T. And in here, let's actually take a parameter that we would like the hero to be called, and this will be where T is of type hero. Let's give ourselves a little bit of room here and close the brackets. Now in here, we actually need to create this T, right? We still don't know what it is, but we need to actually generate the T. So let's say T, new hero, is equal to T, new T, parentheses. Now, this is giving us an error, and that is because although we know that it is of type T, we don't know if these classes that this T here is going to be, we don't know how it is constructed, right? This mage here could have a constructor which takes in int for its damage, right? Whereas the warrior might not, and then the archer might have a constructor that takes 5 arguments. So we don't know. The compiler won't know for sure. So it could actually throw a runtime error, right? Now we can fix this by adding an additional constraint to our generic method, and that is to tell the compiler that whatever we send into this function, it will have a constructor with no parameters. Okay, we are saying that this function will only accept types where the class has no parameters in its constructor. So now that we've gotten rid of our squiggly here, we can actually return new hero. New hero. And there is our generic function. So let's try this out. Let's say var archer equals hero factory, and let's send in archer, right? And then it's asking for our hero name. And I didn't actually fill that out. So as we know that this is of type hero here, we can say new hero, and it has a name, and we can say hero name. What's an archer's name? I don't want to do Legolas's like everybody does that, but the show must go on. Legolas, and I bet you I spelled that wrong. Legolas, what else? So this works because archer has no constructor, but also that it's got no parameters in the constructor. If we wanted to change this to mage, it's going to say, no, you have told us that the object that you're trying to construct has a constructor with 0 parameters. All right, so we can actually now in a generic function generate objects as long as the type that we send in has a parameterless constructor. Cool, so as you can see, generics can be super powerful. They can make your code dry AF by allowing you to reuse code snippets. And really, you've almost learned everything there is to know about generics. Like, I do want to show you one more thing. So we've got our heroes here. Cool. But let's say we've also got, I don't know, a chair, right? We've got a chair and we've got a manager. All right, so this could be a furniture store. It could be a game too, because heroes need chairs, and a manager of an inn or something, I don't know. And these are all super unrelated objects, and none of them can really derive from one another, right? Like, I'm not gonna make a chair implement hero, because that would be stupid. But if someone makes a game of that, give me credit at least. All right, so I'm just trying to think of a scenario. Say you're making an MMO, right? And let's actually change this to the anvil. So say you're making an MMO and you've got a mini map, and let's actually change this to be more relevant. Let's call this a mailbox, right? Let's say all these things have a shared job, and that is to ping your map, okay? We obviously can't derive anvil from hero, okay? That wouldn't make sense. So let's make a public interface, and this will be of iping, and then this just has a required function called ping map, like that. Okay, so then our mailbox will implement iping, and it will have that function there. And I'm not gonna actually implement it, but let's just assume that that map shows a map icon on the mini map, right? And then anvil will do the same, and hero will do the same. Let's just assume that, like, it shows the class icon on there. This could possibly be overridden or something on these derived classes. So now these seemingly completely random objects, we can now write a function that can action any of them. So this will be of type, this will return type void, and this will be ping map, and this will take in a type of t. And this will type, the actual data will be t, so let's just say input object. And our constraint here will be where t is iping. And now we can call input object.pingmap. So now an anvil, a mailbox, and archer, warrior, mage, like any type of hero, we can now reuse one function to perform different logic on all of them, right? And they're all actually doing different things. They're showing different icons. Like if it's a hero, it could show up in red, or it could show up on green if you're in a party or something, you know? So that's how you can mix generics with interfaces to create like true code reusability. So there it is. That's generics. I hope my use cases were nice and easy to understand. I probably should have gone over this one in my head a little bit more, pre-planned it, but I think it turned out all right. If you learned something, or if you enjoyed the video, subscribe. Let me know in the comments if you enjoyed it, and if there's a topic that you would like me to cover, maybe you're having trouble with something. Also, if you're feeling lonely, come over into my Discord, have a chat, we'll talk the shit. Let me know about the game that you're making or something. And yeah, I think that's it. So I'll see you in the next video. Ciao.